Okay, so I hope we are recording right now. So this is the recorded version para maging guide nyo if gagawin nyo na yung activity. So first things first, I uploaded the right format na hopefully kasi yung una is nakagilid pa rin pala yung na-upload ko. So for starting activity 2, you can apply na itong naka-centered na border natin. Okay? So yeah, our report number 2 is propeller design. Same lang din naman yung content ng ating heading, yung name, instructor name, date, section. You all know that na. So for report number 2, the guidelines are all in red, and yeah, I will be explaining all of the figures, all of the table, all of the formulas. But regardless, all formulas, try to put it in the center para hindi magulo yung format natin. And label nyo yung figures and tables. So here are the instructions. Same lang siya sa ating activity 1. So for the mission profile, yeah, as you can see, it is the first part natin, mission profile, ano? Okay, wait a second. Okay, so going back. Yeah, ano bang laman ng ating mission profile? It says here, background about your airplane in 416. So, ang pinakalaman lang niya, pretty much, if your aircraft is trainer, which I believe lahat naman trainer aircraft, give a little bit of background. And gusto ko din makita dito yung goal or objective ng inyong conceptual design. Pretty much background lang talaga siya ng aircraft nyo for year 416. I would like to see din yung inspiration for, syempre, engine configuration. And whether are you aiming ba to introduce better systems? Ano ba yung may i-offer na better ng inyong aircraft? Then, what type of wing ba are you aiming for? Dihedral ba? Cantilever ba? High, mid, or low wing ba? And especially yung reference aircrafts. Saan inspired yung aircraft ninyo for 416? So, it could also be, pretty much, it could be the rough background, initial. Okay? Now, for the specifications, the first part, you can see their red values. So, assume values for yung mga red na yan. Ano-ano ba yan? Yung ating brake horsepower, yung ating maximum revolution per minute, and yung ating maximum forward velocity. So, yung lahat ng naka-red dyan ay i-assume natin. And yung naka-black, especially itong propeller airfoil section rather, we will use Clark Y, all of us. Then, we would be using yung aspect ratio na 6. And kindly take note na standard sea level condition yung ating gagamitin, especially when it comes to the computations. Now, for the design chart, yan lang siya. Paste nyo lang yung design chart. Hopefully, you can use, I think sa AutoCAD, possible yun na ma-center siya. Kasi I think meron pa tong konting pagkakatabingi para madali sa inyo mag-project. You can always rotate naman. Okay? Now, yan, take note yung chart na yan. Now, we have the third part, which is the propeller diameter. We would be getting the propeller diameter. How? First, diba, na-discuss natin yung about sa C sub S. Okay? Now, natakal din natin itong formula na to for our discussion. I believe, binigay ko naman yan. So, yeah, using C sub S, get the blade angle, beta, the propeller efficiency, and advance ratio. From where? From this figure, right here. So, how would you get it? For blade angle, di ba? Nandito sa baba yung CS ninyo. Wait lang. Wala yung aking... Okay, nawala. Take note ha. Nandito yung CS ninyo. Then, project it up. Then, pag tumama siya sa broken line na ito, as you can see, yung line of maximum efficiency for C sub S, using CAD, get nyo yung value kung saan siya tatama. Let's say, tumama around dito. So, isang angle siya mag-fall under. So, 25 to 30. You can use CAD to get the values accurately for the angle. Anyways, the next thing that you would be getting is yung propeller efficiency. How would you get the propeller efficiency? As you can see, it is indicated dito sa, wait lang, hindi na naman siya dito sa ating, ayan o, left part ng ating chart. Ngayon, to get the propeller efficiency, again, using your CS na nandun sa baba, project it up, then pag tumama na sa highest or peak ng curve ng isa dyan, let's say, somewhere here, yeah, somewhere there, pag tumama na siya sa peak ng curve, project nyo siya to the left. And syempre, makukuha nyo na yung value ng propeller efficiency. Then, use AutoCAD and interpolation to get the exact value. So, that is it for the propeller efficiency. Ano naman yung kasunod nating kailangan kunin? The advance ratio, which is indicated dito sa ating right side. Sorry about that. Itong sa right side. How would you get your advance ratio? So, again, using your C sub S, project up, then, kapag tumama na sa broken line na ito, katulad nung sa ating bleed angle, pag tumama siya sa broken line, which is the line of maximum efficiency for CS, project naman natin siya to the right in order for us to get the advance ratio. Then, again, use CAD and interpolation for the exact values. So, I am assuming na lahat kayo is familiar na when using CAD and interpolation to get your values. Okay? So, with this, you now have, di ba kasi ang formula for your advance ratio is V over ND. Now, ano bang hinahanap natin for the third part? Yung propeller diameter natin, diba? Diameter D. So, concerned tayo na makuha siya. Let's say, nakuha na natin yung blade angle, yung propeller efficiency, and yung advance ratio. Now, to get D, we would use the formula for advance ratio. So, we just substituted. Then, yeah, you would be getting your diameter na in inches. Okay, so our fourth part is yung ating hub diameter. For this, you would be using C first to get yung ating hub diameter. Now, saan magsisimula yung C? Ay, saan magagaling? I mean, yung C. So, we have here yung how to get C. We would be using the radius, which is, of course, the half of diameter, and yung ating aspect ratio, which is 6. Then, as you get C, you would be getting na yung ating hub diameter. Kasi meron ka ng C. You just kindly use this formula to get our hub diameter. Okay, what's next? So, what's next is hub thickness. Okay, so basically, use nyo lang tong formula na to get the hub thickness. Diba, nakuha naman na natin yung C dito. Divided by 2, then just add yung 0.25 inches natin. Then you would be getting the value of your hub thickness in what unit? Inches. So just kindly be careful kasi may mga parts tayo na like for part 5, ang kailangan natin is in inches. But there are certain parts as we go on to the activity na kailangan natin ay feet. So just kindly be careful sa inyong units. So the next section, the next part I mean, is yung ating blade station. So using your radius, which is again half the diameter, station. So now that you have your diameter, station it using this table. Paano? Start with station 0, which is indicated there 20% of the propeller radius. Kasi, di ba, na-discuss natin sa lecture na elements inside the 20% of radius contributes no thrust. Yan. So, indicate ko naman dyan, no thrust exerted in 20% radius. So, yung station 0 natin, mag-start siya sa 20%, 0.2, which basically means 20% ng ating radius. So, we have an example right here para madali na lang intindihan. So, at station 0, 20% ng radius. Then, at station 1, 30%. Then, so on and so forth as we reach station 8. Okay? So, the next part is part 7. So, part 7, we would be using the curve. So, just kindly paste this curve, this blade form curve. Now, saan natin gagamitin yon to get our first the blade width per station. So, diba, nakuha na natin, na-station na natin siya from our previous part. Balik tayo. Yan, na-station na natin siya, na-indicate na natin yung 0.2, 0.3, 0.4. Now, as you may see dito sa, wait lang, ito natin. Kaya ba? Okay. Yan, as you may see dito sa ating curve, nandun siya sa baba, yung na-indicate natin na stations. So, using this, the values for your R over R, project it up, and then when it hits the B over D, etong curve na to, na propellers 5868-9 and 5868-R6, kasi dito magpo-fall yung ating clockwise. So, itong curve na to, yan, I hope kita, ano? So, when it hits that curve, project it to the left. Then, again, use CAD to get the distances per station. Okay. So, that's how you get your B over D. Kasi ito siya. Ito yung mga values niya. So, when you project it to the left, you would be able to get the value of your B over D. So, once you have your B over D, balik lang tayo doon. Okay. Once you have your B over D, you can get the blade width, which is B, using this formula, basically. Okay. So, again, the blade width B should be in inches. Okay. I hope you are following. So, again, yung curve na tinignan natin is itong curve na to, B over D. Itong, yan, curve na yan. So, using the same graph, we are concerned to finding naman for our 9th part, our blade thickness, which is H. So, we have the formula right there, where H over V is from figure 2. You would be getting the values from figure 2, blade from curve all propellers. So, use blade from curve. Again, Balik tayo dito. Using yung ating R over R. Ayan. Project it up. Then when it hits the curve for H over B, which is for the all propellers, hanapin yun. Okay, ito. Okay, wait lang. Okay. So, going back dito sa ating figure, sorry. Ito yung medyo, ano lang, malabo kasi yung picture. So, ito yung curve ng H over B. So, anong napapansin nyo? Hindi siya abot dun sa station natin ng um, station 0 and station 8. So, I put their instructions na i-extend nyo yung curve para magkaroon siya ng tangent sa ating station 0 at station 8. Kasi nga, ganito lang yung curve niya. Diba? Hanggang dyan lang. Tapos, hanggang dun lang. So, hindi siya, just make sure na i-extend yung curve para magkaroon ng tangent point pa din. Para makakuha pa rin tayo ng value. So, again, you would use the blade form curve again using yung ating R over R, project up, then when it hits the curve, project to the left kasi as we go back, andito yung ating H over B. Ayun siya. H over B natin ay nasa left side. Okay, so again, use CAD to do so, to project. Then, yeah, you would be getting the H over B per station. So, you now have your H over B. What now? You can get the blade thickness, which is H, by multiplying your H over B per station to your blade width using this formula, pretty much. So, again, blade width is from section 8. So, naka-numbering naman yan. So, madali siyang sundan. So, again, reminders, use CAD to measure intervals and increments in the figure. So, use interpolation para accurate yung mga values na makukuha niyo. Again, I trust that you all are familiar with interpolation na. Now, I already told you to extend your curve so that it would have a tangent point at some point ng station 0 and station 8 natin. Now, we proceed to our 10th part. Pretty much makikita ko lang, sample figure lang to indicated naman dyan. Makikita ko lang is blade plan form with 30% correction at the shank. Tapos, your blade thickness distribution, your pitch distribution, pretty much sa drawing lang to. Okay? I would like to see, syempre, nagkakaroon na ng build yung ating propeller. Nagkakaroon na siya ng shape. Dahil dun sa mga sinusolve natin. Nakakapag-set na tayo ng stations, kuha na tayo ng blade width, ng blade thickness. So, using those, you would be able to construct your blade plan, to show rather your blade plan form, your thickness distribution, and pitch distribution. So, now, for the 11th part, we have the rotational velocity, which is V sub R. Yung formula niya is 2 pi Rn. So, note na yung, diba I told you kanina, yung in-assume natin na N is in RPM, pero yung kailangan dito is in revolution per second. So, just kindly make sure na magko-convert kayo. So, R is again the station radius in feet. That's why, kung napansin nyo kanina. Balik tayo sa station radius. Yeah, meron tayo dyan na indicated in feet. So, we would use that sa ating part 11. So, again, take note yung sa n revolution per second siya. Then, let k be 2 pi n para hindi na kayo mahirapan mag-substitute. Para ang i-substitute nyo na lang is, yeah, use this formula V is equal to KR na lang. Para substitute na lang kayo ng substitute. Hindi na kayo paulit-ulit na gagamit nung 2 pi n. Okay? So, madali naman yan. I think gets nyo naman na kung paano. Kung nagdadalawang isip sa Excel calculator, every now and then to check. So, yeah, that's pretty much it for the 11th part. Now, for the 12th part, we have the computed blade angle. Once you have your rotational velocity na, which is yung nasa part 11, use your assumed value of V sub F, yung initial assume natin kanina. Diba? Nag-assume tayo ng ating maximum forward velocity. So, use those. Just kindly, ayaw niyo mag-show up. Okay, kindly use this formula. Meron ka ng VF na inassume kanina and yung VR dito nanggaling sa ating 11th part. So, wait. Okay, sorry. We now move forward to our 13th part, which is this figure. Just kindly paste this figure and table as we will be using yung values na nandito sa ating next parts. Let's start with part 14, which is our actual blade angle. So, kindly take note of this formula. So, use the value of alpha from 13. Ito, okay. As you are seeing there sa ating table, itong -5 for 0 station, -1.5 for first station. Yeah, you would be using those corresponding alpha from the 13th part and computed blade angle. So, you would be able to get the actual blade angle per station using the formula. So, plus minus siya kasi yung value ng ating alpha is may plus and may positive and may negative. So, kaya siya naka plus or minus there. So, you would be getting, again, use the value of alpha from part 13, then the computed blade angle from part 12. So, going back. Ayan, computed blade angle from part 12. Makukuha nyo na yung actual blade angle per station. Okay? So, moving forward, we have the airfoil characteristics for Clark Y. Again, kaya ko in-indicate na Clark Y yung gagamitin for everyone. So, uniform yung ating gagamitin na values for this. So, A sub 0, angle of attack at 0 lift, and our CBO. So, saan natin yan gagamitin? So, let's start. So, for part 16, which is our lift coefficient, we would use this formula. So, saan manggagaling to? Itong ating alpha here. So, this would be from part 13. Okay, balik tayo dun. Dito. Yung table na yan. Then, angle of attack at 0 lift, dito siya sa ating part 15. Together with ating ASAPO. Okay? So, again, we would be getting this from part 13, this from part 15, and also this from part 15. Right there, we would be getting yung lift coefficient natin for each station. Now, for our 17th part, which is the helical velocity, which is V sub h. So, pretty much, ano lang siya, you would be using your VR and VF, forward and rotational velocity. So, put in the values, right then you would be getting your helical velocity in feet per second. So, simple as that. Now, for our 18th part, which is the lift. So, we are all familiar with this formula right here. So, to get the lift, syempre, 1/2 multiplied by our sea level, standard sea level condition density, then our helical velocity from our part 17 multiplied by surface area in feet, in squared feet. Saan manggagaling to? Yung surface area natin per square feet. So, balik tayo dun sa part 8 natin. Okay, dito siya manggagaling sa blade width in inches. So, convert nyo siya. Again ha, kindly take note kung kailan kayo magko-convert, when to use feet or inches. So, for this one, we would be using squared feet. So, we need to convert the values that you would be getting from your part 8, convert it to feet squared by using this formula. So, pinrovide ko na din dyan. So, yung CL naman natin, which is yung ating lift coefficient that you would be getting from part 16. Okay? Itong table na to. Doon siya magagaling. So, we now proceed sa, yeah, pretty much itong picture na to, ano lang, pinapakita niya yung, pero you don't have to put this anymore. Pero, na-discuss naman na natin yung blade element theory. So, pinapakita lang niya kung ano yung application sa blade element theory. Kasi, diba, pretty much, we are sectioning the airfoil doon. We have these things called elements, depending sa ating station. So, ayan. Yan yung representation ng blade element theory natin. So, second to the last part na to, actually, part 19, which is the lift versus station. So, simple lang. Graph or plot your values using AutoCAD or Excel, which wherever you're more comfortable with using. Again, I am expecting to see curve ha, or I am expecting to see plots. I don't want to see na magpa-flat na naman yung, I mean, you all know what I'm talking about. Yung mga nalilito, I would say nalilito sa pagpa-plot ng values na I would just like to see the relationship. Okay? So, clearly, magmumukha yung curves, probably. So, depending sa values ninyo. But I would just like to see the relationship between lift and station. Lift with regards to our station through a graph. Our last part is the drag coefficient, which is CD. So, simple lang din. To get CD, we need our CDO. Saan natin siyang part makikita, diba? Minention ko kanina yun sa part 15. So, let's go back sa part 15. So, andun siya. Ayun. Okay. Again, uniform to lahat kasi pare-pareho tayong Clark Y yung gagamitin. So, now that you know where CDO would be coming from, syempre, the other parts pa nung formula. So, our CL would be coming from table 16, which is right here. So, you would be using the values per station ng ating CL doon. Then, corresponding stations yan, ha? Then, to finish off the formula, syempre, meron tayong pi. Meron tayong Oswald's efficiency factor, which is 1. I indicated there na para wala nang malilito. Then, yung ating aspect ratio. Sorry, hindi na nasakto yung bilog. Okay. So, using these, you would be getting your drag coefficient. And that pretty much sums up our second propeller design activity. So, I hope naka-follow po lahat. Okay, thank you.